Good afternoon, children. How are you all? Welcome to Sanvi e-learning services. Today we are going to discuss about whole numbers. The second chapter, the name of the chapter is whole numbers. Okay. So in the part of whole numbers, the aim of the topic is knowing about whole numbers and solving exercise from 2.1 to 2.3 problems. It means solving exercise 2.1, 2.2, 2.3 problems. Okay. And the agenda is introduction of whole numbers, understanding about successor and predecessor, representation of whole numbers on number line, addition, subtraction and multiplication of whole numbers on number line. Okay. And properties of whole numbers. Okay. So in previous class already we have discussed what is whole number, what is successor and predecessor, and representation of whole numbers on number line, addition, subtraction, multiplication of whole numbers on number line. Okay. So today properties of whole numbers. Today we are going to discuss about properties of whole numbers. So closure property, the properties are closure property, commutative property, associative property and distributive property. Okay. So in these properties, in previous class already we have discussed closure property. Okay. So what we have discussed about closure property? About closure property, we have discussed that the sum of any two whole numbers is always a whole number. It means when we multiply any two whole numbers, always we get a whole number. Okay. When we add any two whole numbers, always we get a whole number. And product of any two whole numbers is always a whole number. Okay. So this is the commutative closure property. And closure property is not possible under subtraction and division. Already we have shown. Okay. So today commutative property and associative property and distributive property. Right. So first of all, commutative property. What is commutative property? Commutative property is nothing but, so when we add any two whole numbers in any order, we get the same result. Okay. So when we add any two whole numbers in any order, we get the same result. Okay. So if we get like that, it is called a commutative property, and that result also we get whole number. Okay. So let us see how it is. Now we are going to discuss about commutative property. Let us see what is commutative property. Commutative property. Okay. Commutative property. If we add any two whole numbers, okay, suppose A and B are any two whole numbers, okay, for any two whole numbers, suppose the two whole numbers I am taking as A and B, okay, for any two whole numbers A and B. So when we add these two whole numbers in any order, we get the same result, and that result is always a whole number. Okay. So here A and B we have taken to any two whole numbers. So we added them straight and reverse order, A plus B and B plus A. So if A plus B is equal to B plus A, then it is commutative property under addition. Okay. If a plus b is equal to b plus a, it is called commutative property under addition. Okay. And in the same way, when we multiply any two whole numbers in any order, when we multiply any two whole numbers in any order, we get the same result, and that result will be also a whole number. It means here two whole numbers we have taken as a and b. So when we multiply them in straight and reverse order, we get the same result. Okay, so this is called commutative property under multiplication. This is commutative property under multiplication. So let us see examples. You take any two whole numbers. Suppose I am taking two whole numbers, we have taken a and b now. Suppose a is equal to, I am taking 2 and and b is equal to, I am taking another whole number 3. Okay. So add them in straight and reverse order. First of all, we are checking a plus b is equal to b plus c. Okay. So the first one we are checking a plus b is equal to b plus a. Right. So a plus b, a value is 2 given plus b value 3 given is equal to b plus a, b value 3 given and a value 2 is given. So here we get 2 plus 3 is equal to 5 and also 3 plus 2 is equal to 5. Right. So did we get the same result in LHS and RHS? Yes. See, we have taken two whole numbers 2 and 3 and we added in straight and reverse order. We get the same result, and this result always a whole number. It means when we add any two whole numbers in any order, we get the same whole number. Right. If the whole numbers are a and b, a plus b is equal to b plus a. The same way, when we multiply any two whole numbers in any order, we get the same result, and that result will be a whole number. Let us see the second one. What is given? A into b. Okay, a into b is equal to b into a. So we are multiplying two whole numbers in straight and reverse order. A into b is equal to b into a. So now check this condition. See, a value we have taken 2 and b value we have taken 3. So when we multiply them, we get, see, a into b. It means a value is 2 and b value is 3 is equal to b into a. B value we have taken 3 and a value we have taken 2. So 2 into 3 is equal to 6 and 3 into 2 also 6. See, when we multiply any two whole numbers in any order, we got the same result, and that result is always also a whole number. Okay. So like this, for any two rational numbers a and b, if a plus b is equal to b plus a, that is called commutative property, and it is under addition. If plus symbol, if we add means it is commutative property under addition. So if we multiply them, it is called commutative property under multiplication. Okay. So if a into b is equal to b into a, it is called commutative property under multiplication. Okay. Now what about subtraction and division? Commutative property is subtraction and division. Okay. Commutative property is not possible under subtraction and division. Okay. So here we write the note. The note is note. Commutative property is not possible under subtraction and division. commutative property is not possible commutative property is not possible under subtraction and division. Why it is not possible under subtraction and division? Let us see. See, for example, take any two whole numbers. Okay. Take any two whole numbers. Suppose I am taking two whole numbers. Any two whole numbers. Okay. For example, see, I am taking a whole number. Suppose A is equal to 3 and B is equal to 5. A is equal to 3 and B is equal to 5. So when we subtract them, okay, 3 minus 5 in state order is equal to reverse order 5 minus 3. Is 3 minus 5 is equal to 5 minus 3? No. 3 minus 5 is equal to we get minus 2 and 5 minus 3 we get equal to. So the result is not same. So that is why commutative property is not possible under subtraction. In the same way, division. Under division, okay, suppose, see, for example, we have taken A is equal to 3, 3 by 5. A is equal to 3 and B is equal to 5. 3 by 5 is divided by 5 by 3. Okay. It means when we divide 3 by 5, it means 3 divided by 5. It is not possible. Let us see here. Division 3 divided by, if 3 divided by 5 is not equal to 5 divided by 3. Okay. So that is why commutative property is not possible under division. Right? So this is about commutative property. And next, third one is associative property. The third property is associative property. Let us see what is associative property. Children, listen carefully. These properties are very, very important. Okay, if you understand these properties, then only you can solve the problems, exercise problems, right? Now, third property is associative property. Associative property. So what is associative property? Let us see. It is also same like commutative property. So associative property is saying that for any two whole numbers, for any three whole numbers, for any three whole numbers, for any three whole numbers, suppose the three whole numbers I am taking A, B and C. The three whole numbers I am taking. Okay. So first of all, we have to add these two whole numbers A and B. Okay. And then after the third whole number we should add left side. And right side, write the first whole number separately and add the next two whole numbers. It means for any three whole numbers A, B and C, A plus B plus C is equal to A plus B plus C. So this is associative property under addition. Adding means it is addition. Okay. And under multiplication, it means A into B into C is equal to A into B into C. So this is associative property under multiplication. under multiplication. Okay. So for any two whole numbers for any three whole numbers a, b and c, if a plus b plus c is equal to a plus b plus c, it is associative property under addition. For suppose if a into b into c is equal to a into b into c, it is associative property under multiplication. Okay, both results should be same, LHS and RHS. So let us see the examples. For example, you take any three ABC values. Suppose I am taking, let A is equal to 2, B is equal to 3, and C is equal to, I am taking 5. Okay, A is equal to, B is equal to 3, and C is equal to 5. Now check associative property under addition. Okay, so what we get, what is the condition about addition? A plus B plus C is equal to A plus B plus C. Okay, this is the condition for addition. Okay, this condition should be satisfied. Let us see whether this condition satisfies or not. See here, A value we have taken 2 plus B value we have taken 3 plus C value we have taken 5. Okay, substitute A, B and C values. And here also A value we have taken 2 plus B value is 3 plus and C value 5. Okay, now add them here. 2 plus 3, how much we get? 5 plus 5. Here also 2 plus, first of all we should add the inside bracket inside values. Okay, 3 plus 5, how much we get here? 3 plus 5 is equal to 8. Now add LHS and RHS. 5 plus 5 we get 10, and here 2 plus 8 also we get 10. See, in LHS and RHS we have got same result, 10 10. Okay, and also it is a whole number. So like this, for any three whole numbers a, b and c, if a plus b plus c is equal to a plus b plus c, it is associative property under addition. And let us check under multiplication. Okay, under multiplication. Under multiplication, what condition should be satisfied? A into b into c. It means we have to multiply first two whole numbers and after third whole number. So a into b into c is equal to a into b into c. Okay. So now check this condition whether it is satisfied or not. See here, a value we have taken as 2 and b value we have taken 3. So in the place of a, b, c you put their values. Okay. Now into c value we have taken as 5. So in the place of c write 5, and here also a value is 2 into b value is 3 into c value is 5. Okay, now multiply them. 2 into 3, 2 3 is 6 into 5 is equal to, here also 2 into 3 into 5, 3 5 is 15. It means first of all we have to multiply bracket values. Okay, inside the bracket what are given, that values we have to multiply them. Now multiply them here. 6 into 5, 6 5 is 30 is equal to, here also 2 into 15, it means 15 2 is 30. See, we have got same result in LHS and RHS. So like this, if we get the same result in LHS and RHS, so it is commutative associative property under multiplication. Okay, if we add any three whole numbers in any order, if we get the same result, it is associative property under addition. And if we multiply any three whole numbers in any order, if we get the same result in LHS and RHS, that is called associative property under multiplication. Okay. Next, distributive property. Next is distributive property. So what is distributive property? Let us see. Distributive property. Now The fourth property is distributive property. Fourth one, distributive property. Distributive property. So distributive property saying that for any three whole numbers, same again, okay, same like associative property. For any three whole numbers, for any three whole numbers, for any three whole numbers, suppose that three whole numbers I am taking A, B and C. Okay, for any three whole numbers A, B and C, the distributive property is A into B plus C. Here see, addition is there and subtraction is there. Sorry, multiplication is there at a time. Okay, addition under addition and multiplication. So the first whole number A we are multiplying with B and C. It means A into B plus C is equal to. So A into B plus C is nothing but this whole number A we have to multiply once with B and next multiply once with C. Okay. So first of all this whole number A multiply once with B. What we get here? A into B. Okay. And next multiply next with C. Here middle plus symbol is there now. Right plus symbol as this A into C. So this is distributive property under addition and multiplication. Okay. So what is distributive property? For any three whole numbers A, B and C, A into B plus C. It means when we multiply the first whole number with other two whole numbers, and this LHS and RHS value both are should be same. It means A into B plus C is equal to A into B plus A into C. Okay. So let us see the example whether it is correct or wrong. Example. Take any ABC values. Suppose I am taking A is equal to 1. Okay. B is equal to 5 and C is equal to 10. Okay, any whole numbers we can take in the place of A, B, C. Now check this condition. So what we get when we substitute this A, B and C values? See here, A value is 1 into B value is 5 plus C value is 10 is equal to A into B. A value is 1 into B value is 5 plus A into C. A value is 1 and C value how much it is? 10. Okay. C value is 10. Now simplify LHS and RHS whether we get same or not. See, first of all 1 into, first of all this bracket value simplified. 5 plus 10 we get 15 is equal to, here 1 into 5 it means 5 ones are 5 plus here also 1 into 10 it means 10 ones are 10, right? Now 1 into 15 means 15 ones are 15 is equal to, here 5 plus 10 how much total? How much? 5 plus 10 is equal to 15. See, we got same result in LHS and RHS, right? So, what is distributive property? Distributive property is nothing but for any three whole numbers A, B and C, A into B plus C is equal to A into B plus A into C. So, this is the distributive property under addition and multiplication, right? And so these are the four properties, very important. So first property, closure property. Okay. Second one is commutative property, and third one is associative property, and this last fourth one is distributive property. Okay. And the next we have again identities. So let us see what are the two identities. Observe the textbook about the identities. It is given identities. So we have two types of identities are there. One is additive identity and second one is multiplicative identity. Okay. First one is additive identity and second one is multiplicative identity. Let us see what is additive identity and what is multiplicative identity. Here see the heading identity for addition and multiplication. Okay. So what is additive identity and what is multiplicative identity? So before understanding about what is additive identity and what is multiplicative identity, so first of all, observe this table, first table. Okay. See, in this first table, it is given that, see, here he has taken some whole numbers and that whole numbers added with 0. Okay. So 2 plus 0. So when we take a whole number 2 and when we add it, when we add this, okay, 2 plus 0. 2 plus 0 is equal to 2 only. It means 9 plus 0 is equal to, again we have got 9 only. When we take 2 and if we add with 0, again we got 2 only. When we take 9 and when we add with 0, 9 plus 0, again we have got 9 only. The same way, 0 plus 11 is equal to 11 only we get. And 0 plus 25 equal to also we get 25. It means when we add any whole numbers with 0, again we get the same whole number. Okay. So when we add any whole number with 0, again we get the same whole number. Okay. See here we have taken 2 and added with 0, again we have got 2 only. Next, one more whole number we have taken 9, added with 0, again we have got 9 only. Next, again whole number 11 we have taken, added with 0, again we got same whole number 11 only. Next here 25 whole number we have taken, added with 0, again we get same whole number. Okay. Like this, when we add any whole number with 0, again we get the same whole number. So this is the specialty of 0. Okay. So what is the specialty of 0? When we add any whole number with 0, again we get the same whole number. So this is the specialty of 0. So that is why 0 is called additive identity. Why 0 is called additive identity means the specialty of 0 is when we add any two whole numbers with when we add any whole number with 0, again we get the same whole number. That is why 0 is called additive identity. So this is the specialty of 0. Okay. So 0 is called additive identity. Remember that 0 is, what is additive identity? It means you have to say that 0. Right. And next, what is multiplicative identity? Observe this table. Multiplicative identity. See, when we multiply any whole number with 1, again we get the same whole number. Okay. In first table, what we have discussed, when we add any whole number with 0, we got the same whole number. So that is why 0 is called additive identity. But here multiplicative identity means when we multiply any whole number with 1, again we get the same whole number. See here, 9 into 1, 9 ones are 9. Okay. Next, see 5 into 1, 5 ones are 5. 11 into 1, 11 ones are 11. Okay. It means, see, 2 into 1, 2 ones are we get 2 only. 3 into 1, 3 ones are 3 only will get. Okay. 5 into 1, 5 ones are we get 5 only. Right. 100 into 1, 100 ones are we get 100 only. It means when we multiply any whole number with 1, again we get the same whole number. So this is the specialty of 1. So that is why this 1 is called multiplicative identity. 1 is called multiplicative identity. This is the specialty of 1. So what is the specialty of 1? When we multiply any whole number with 1, again we get the same whole number. This is the specialty of 1. So that is why 1 is called multiplicative identity. We are multiplying means it is multiplicative identity. And what is the specialty of 0? When we add any whole number with 0, again we get the same whole number. So this is the specialty of 0. So that is why 0 is called additive identity. We are adding that, so that is called additive identity. So remember children, what is additive identity and what is multiplicative identity? 0 is the additive identity and 1 is the multiplicative identity. Okay. So let us see now exercise 2.2. Right, exercise 2.2. So before completing this exercise 2.2, okay, first see the first bit. See the first bit. It is given. Give the results without actual performing the operations using the given information. Okay. See here. The first one is without multiplication. We have to say the answer. Okay. See here, 28 into 19. He said that 532. It means 28 19 is a 532. In the same way, 19 into 28, how much? Same result we get. No, we get same result, 532. So how you are saying we get same result? Because when we multiply any two whole numbers in any order, we get the same whole number. Which property it is? It is commutative property. Okay, commutative property under multiplication. Let us see how these properties will come. So, see children, here the question is given, the first bit question. Without performing multiplication, we have to say the result. Okay. See exercise 2.2. The first question is given 28 into 19 is equal to 532. Okay. Then here asked 19 into 28. How much? Okay. So we get the same answer, that is we get the same answer, that is 532. Okay. So how you are saying we get same answer 532? Because of commutative property. Commutative property saying that when we multiply any two whole numbers in any order, we get the same result. Okay. So here the property is involved commutative under multiplication. Here we multiplied now. So here the property is involved commutative property under multiplication. Okay. Now see the second one. 1 into 47 is equal to 47. Then 47 into 1 is equal, he said, dash. So what is the answer? We all know that we get same answer 47. Right. 1 into 47 we got 47. 47 into 1 is equal, we got same 47. Which property is involved here? Same commutative property under multiplication. Okay, commutative property under multiplication, same property involved here, right? Or multiplicative identity. In the same way, and third one is given a into b is equal to c. Then b into a is equal to also we get c only. A into b is equal to c. Then b into a is equal to also we get same answer c. Here also commutative property under multiplication. Okay, same property involved here. Okay, right? Commutative property under multiplication. And the fourth one, 58 plus 42. 58 plus 42 is equal to 100 given. Then 42 plus 58. 42 plus 58 is equal to. We get same result, 100 only. According to which property? See here, 58 plus 42 is equal to 100. Then 42 plus 58 is also equal to 100. It means here what property is involved here? Same here also, commutative property. Commutative property under addition. Here we have done addition. So here commutative, this property is involved here, commutative property under addition. Okay. So in the same way, you write the remaining children. Okay. So write the result first and then after you write which property involved there. Okay. And after that, once see the last bit, that is 8th bit, match the following. Here some addition and multiplication and some numbers are given. So here the properties are given. So which property is involved here? Okay, see here 1991 plus 7 is equal to 7 plus 1991. So which property it is? It is commutative property under addition. So what is the answer here? See, commutative under addition. C is the answer. Like that, you match them. Right? So this is your homework, children. Thank you. Thank you all.
Okay. Good afternoon, students. Good afternoon, all. Welcome back to our science class. Now we are in chapter 2, playing with magnets. Okay, once let me recap what we have learned till last class. Okay. Now let me recap once. We have learned about importance of magnets in our daily life and where do we use magnets. Okay, discovery of magnets and shapes of magnets, properties of magnets. Am I audible to you? Okay. And properties of magnets, magnetic materials and non-magnetic materials, and definition of magnet. I hope that all you have noticed that what is a magnet. I already told you to note down this point. Once again, I'll repeat this, children. What is magnet? Because we are going on learning this lesson, magnets, importance of magnets, playing with magnets. Okay. So definitely you should know what is the meaning of a magnet. If anybody asks, you have to answer, right? So an object which is capable of producing magnetic field. Okay, children. Once again, I repeat this. If you want to copy, you can. An object which is capable of producing magnetic field and attracting unlike poles and repelling like poles is called a magnet. So this everyone you should know. Okay, Nana. Now today I am going to explain about. Already we have learned about the story of magnet and separation of iron filling using carbide. Okay. Magnet was this one. Okay, Magnus is a person who so something so was called lodestone. So there was a great story about the invention of a magnet. The natural magnet. Okay, or leading stone. Okay, children. At the same time, I explained about separation of iron fillings from the so all you have done this activity at home. I have given as a homework list. Take an iron, sorry, magnet. If you have a bar magnet, you can do with the bar magnet. So in the pandemic situation, we can't go out. So that's the reason I said whenever the magnet is available to you at home, you can try with that magnet, I said. But I don't know your response whether you have done or not. Again, I'm repeating you. If you have done, it's okay. Not do this. Once again, you try with a bar magnet or a bar magnet. I'll show you the image. Clear image I'll show you. If you have normal magnet, no problem. You can try with the activity. Simple children, take the magnet, roll the magnet in the soil for some time. Then you will see something attractive, some what we call powder like substance will attract the magnet. Okay, some powder like substance will attract the magnet. So after rolling the magnet in the soil, remove the magnet. Try to remove the fillings on a clean white paper sheet. Okay, then that homework I have given. Okay, if you not do, again do. I will show the clear image of magnet. Wait. So, like this. A bar magnet have two poles, north pole and south pole. This is the bar magnet. Now, today our topic is, today we are going to learn about the bar magnet and how it works. Okay, what is the importance of bar magnet? We are going to learn. Next one, I am going to explain about the poles of a bar magnet and finding the direction with the bar magnet, the magnetic compass, and attraction between two magnets. This is our math children today. Am I clear? Once again, to you poles of direction of magnetic compass. The fourth point, attraction and repulsion between two magnets. So these four points we are going to discuss. Okay, all of you sit straight. Please try to pay attention. Okay. Now, so children, when we roll the bar magnet in the soil, we see some iron will be across the bar magnet. Okay, but when you remove the iron from the pan or wherever you have done this activity, so that whatever just you separate the iron filling in the white paper and try to take the bar magnet and keep the below the sheet and try to then you see that iron fillings will be attract the bar magnet. Then after you notice what happens and which side is the iron fillings are attracting more. Am I clear to you? Once again, I repeat. Children, I told you to get the iron fillings from the soil, from the sand. So that iron fillings, just you try with the bar magnet, take the iron fillings in the white sheet, try to rotate the bar magnet below the sheet. Keep the bar magnet below the sheet. Try to move it. When you are moving, you will find what is happening. Okay. So that observation you have to note in the notebook. What we observe here I will explain. So when we take the bar magnet and rotating under it, we will see iron filling attract to more north side, south side, only to end of the pole. In between that, more attraction won't be. So that's why we will not find more iron fillings. We will see some less iron fillings are moving here and there when we are rotating the bar magnet. This is because the two poles have more attraction capacity that we will observe after doing this activity. Am I clear? I hope you all understand. Now, how do we find the directions by using bar magnet? Why is magnet is important? Really, is it helps in the finding of directions? Okay, let us learn this. Now take a bar magnet and try to arrange a stand and tie the bar magnet in between two poles and try to move the bar magnet. Wait for some time. The magnet will rest at some direction. The magnet will try to rest at some direction, whether it is north direction, whether it is south direction. After when it is stops, when it rests at some direction, you can notice that. Okay, children, and do this activity. Now we will note okay, where the color ocean come to rest. Where it will be come to rest? North side or south side. You can repeat this experiment. Place. Suppose you are trying this experiment in your room or outside, wherever you want, you can do this. Have an observation different senses and different places. Okay, children, and always come in the north south direction. This point. Always a bar magnet have two poles. That is north pole called N, south pole as NS direction, north direction and south direction. So always magnets come to in the north direction or direction. In each case, the mark toward the north. This end is known as north pole of the magnet. Okay, children. Now, north pole of magnet is the other end. Which point is known as south pole of magnet. So these both reactions, after having these two observation, different observation, so this property of magnet is called directional property. So when the magnet is moving south side, north side, south pole, north pole, after having this observation, it is finally justify the directional property of the magnet. Am I clear? Shall I repeat once again? So how the direction by using the bar magnet? You have to arrange the stand and tie the bar magnet at the center point. Am I clear, children? Now try to move the bar magnet and wait for some time. Okay. just a point, whether it's not or pole. Have an observation. So this property is called as directional property. Okay, children. Now, about magnetic compass. See, here I am doing magnetic magnetic compass usually a small box with a glass covering it. Have you seen this any time, children? It is like what we call speedometer on the bike. Can you observe on your other vehicle? So, a compass is usually a small box with a glass covering it. And magnetic inside the box in such a way that it can rotate freely, children. See, magnet is a small a magnetized needle. See, look at observe of needle. It is two colors, right? Red and white color. And see where direction, the direction is also visible on the screen. Should be a magnetized needle is coated inside it. Inside. So in such a way, the needle will rotate. Okay. Compass has directions marked on it. Okay. We should know the direction. It needs north-south direction when it comes to rest. So, it can rotate until north and south, mark on two ends of the needle. So, like we can identify the directions whether north or south. So, where we can use the magnetic compass. Children, you know, suppose place. Suppose from Karimnagar to Hyderabad, from Karimnagar to Siddipet, Silla, etc. How do we go travel in far away speeder? Okay. So, what are the indicators? So, driver will follow all the instructions like we will see the speedometer, okay, how much speed the car is moving, all that. There are some signboards at the roadside. Okay. Then, what about aeroplanes and ships? Children, why I am taking this example? Why I have to talk about traveling on on bike or car or a bus, etc. Because we need to know the safety measures when we are traveling. Suppose when we are moving in the bus, so the driver will take all the safety measures like whether his bus condition is good or not, whether air is there or not in the tires, all that. Even sometimes the bus may trouble him. You might have noticed many times. Okay, maybe the bus trouble, so he stops at certain place and he will try to arrange another vehicle for the passengers, or he will make a call to other person, mechanic, etc., and he will take all the safety measures. I think you got my point. What I am trying to tell you, did you understand, children? Suppose if there may be any accident in between the road, he will stop the bus. Even though we will stop our vehicles and we will see, we will try to help. So this is the roadways. Then what about airways and waterways? Nowadays, there are so many import export is happening by the airways and waterways. You know what are airways and waterways? Airways like helicopters, aeroplanes, jet planes, etc. And waterways like boat, ships. Children, yes or no? Yes. How they move. Suppose if there is any problem in the bus, suppose your vomiting sensation is there, somebody want to go for washroom. So if it is really urgent, if we say to driver, he will stop the bus and we will finish our work. Suppose same situation is happening in the flight. Can he stop the flight in between, I mean in the air? Is it possible first? No, it is not at all possible. And suppose if there is any problem, how he can manage? Suppose how the, can we call who ride the, I mean who operate the flight? A driver? No, it's a pilot. How can he know that which direction he is moving, how to go? Because after flying at certain distance, everything is equal in the atmosphere. He don't know which side he needs to move. So that's why children. Sorry, children. Sorry for the disturbance. There is a phone. So, for two, not side outside, all the direction, I mean all the instructions he will get by the this compass. I hope you all understand how the magnetic compass is used in the airways and space. Yes, children. And even though mountaineers also, suppose after they travel, I mean certain distance, they may get confused which direction they are moving. So a compass is used to find direction. The aeroplane and mountaineers and army people also carry this compass, Nana. Why? Because they do not lose their way. So if the compass is there with them, it helps them which direction they are moving, it helps. Children, I hope you all understand. Can I move on to the next topic? Today I have discussed about 2 points, children, about how to use the, I mean, magnetic compass. Okay. And about the bar magnet, how do we use bar magnet directions? I'm going to explain about the attraction and repulsion using the magnetic compass. Bar magnets, okay? Now let me show you the image. See, look at this picture. Test for the magnetism, okay, attraction and repulsion between the 2 bar magnets. Okay, now see, take a metal known as a magnet and bring 2 poles. I said north pole and south pole. See, north pole is in red color, south pole is in green. So when you bring to north pole, south pole, what happens, children? There is an attraction. See the arrow mark. It is okay. Can you see the image? Maximum I zoom, Nana. So if you want to take a screenshot, you can see this. This is called the bar magnet. The red color spot is the north. Green color spot is south direction. These 2 are directions. It is a bar magnet. When I bring 2 bar magnets with opposite directions, south directions to north direction, they will attract. Now I'll take example of second image. In second image, I am showing the north-south and south-north. So 2 same directions. Same, south-south, see same color, green color is there. Now, did you notice the arrow marks are repulsion? I mean, they are not attracting, they are moving far away. Why this is happen? See the another image also. Okay, let us try with the north direction. Okay, north direction and another north direction also they are moving. See the arrows are moving far away. This is because the opposite poles will not be attracted. They will repel. Okay, like pole will be attracted. Okay, now. So I hope after showing this, you will be understand. Can I repeat this once again? Look at the image. Observe for a minute. See the colored parts are clearly looking. The north pole, south pole, north pole, south pole. So unlike poles attract, Nana, simply remember that unlike poles attract, like poles repel. Unlike poles means what? South, north is unlike pole. Okay? South direction and north direction is unlike poles. So unlike poles always attract. Like poles always repel. Okay? Now, so shall I explain once how to make your own magnetic compass? What is the time now? Okay. A magnetic compass function as a pointer to the magnetic north, the local magnetic meridian, because the magnetic needle is not aligned itself with a horizontal component of the Earth's magnetic field. See, look at the magnetic compass here. The magnetic field exerts torque on the needle, pulling one end or pole of the needle approximately toward Earth's north magnetic pole and pulling the other toward the south magnetic pole. Okay, see when you look at the Earth, south-north direction will there it will mounted on a low fixed pivot pointed. In better compass is a dual bearing, so it can be turned easily. Okay, Nana? When held, it lets the needle turn until after a few seconds so out. It's equilibrium orientation. So like this magnetic compass will work. So what I wanted to recap after today's topic, Nana, what we have learned. Once I will. So today we have learned a bar magnet, how the iron filling iron filling, black color spots are there, those are the iron fillings. Exactly, you will also get if you try the experiment with by using the magnet. Okay, so when you try bar magnet or any other magnet, you will get like this iron fillings. So I said that spread this iron fillings on the white sheet and try to rotate the bar magnet below sheet. You will see how the iron fillings will move. I can't say. So if you see that, you will be able to understand. Okay. Now finding the directions by using the bar magnet. So the bar magnet will rest at certain distance and distance place. It rests at the certain place. Now, so we learn about magnetic compass. Okay, magnetic compass is small, which coverage on it and needle inside inserted inside magnetic compass. The magnetic compass has a dial marked as a direction. The magnetic compass will be used in the aeroplanes and in water, mountaineering, etc. And the army people also will use this because of direction problem and they don't know which direction they are moving. That is the reason always carry. Some people will use the watch also, magnetic watch. It know the direction explained to avoid the miss of the way. And also we learned attraction and repulsion in the north and south direction. Okay. Like poles always repulse and unlike poles always attract. And how to use this magnetic compass and the directions also we have learned, and attraction repulsion also we have learned. Okay, so this is today's topic. You have any doubt, you can ask me now. Please wait, Anna, I move on to your responses. Let me see. Yeah, any doubt in this chapter, please tell me now. Can you unmute yourself? Because I go on explain, you don't understand. Children, please tell me. Can you unmute yourself? Gara Shravani. Shravani, can you hear me? Can you unmute yourself, Nana? Show your hand. Shravani. Purple dress. Lekya Charan. Who is listening the class? Both are there. Who is listening the class? Nana, just raise your hand, Nana. Can you hear me? Ah, very good. You can't unmute yourself?
Ma'am, we must ask to unmute, ma'am. Then they will be able to unmute.
Yeah, okay.
There is an option ask to unmute. Just click there, ma'am.
Okay, Nana. There is an icon, Nana. Mute icon. Just you click on this so you can talk to me. If you have any doubt regarding this chapter, please ask me, Nana. Till today. If you want to have any discussion with me, you can ask me. Sharanya, you can't unmute? Click on mute icon.
Yes, ma'am.
Wow, somebody is talking with me. Sharanya?
Hello. 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 And would you class? నేను చెప్పింది మ్యామ్
Who is talking? Pranavi? Pranavi is unmuted. Pranavi, are you talking?
ఎస్ మ్యామ్
Pranavi, how do you feel and after listening these 2-3 classes?
హ్యాపీ మ్యామ్
No, was there any problem, Nana? Are you understanding or you have any doubts?
అండర్స్టాండ్ మేడం
Very good. You know what is the bar magnet, beta?
ఎస్ మ్యామ్
Can you say one? Okay.
ఐరన్ మ్యామ్
Yeah, it is iron. Okay. Bar magnet have 2 poles. I explained, no?
ఎస్ మ్యామ్
Okay. So who invented it? Is invention or discovery, Nana, magnet? You know what is the difference between invention and also the discovery?
ఎస్ మ్యామ్
Yeah. I want to talk to Sharanya. Please, Sharanya, unmute ma. You can't unmute. Fine. Now. Hansika. Hansika and Shanmukha Priya. Hansika and Shanmukha Priya. Can you hear me? Please unmute, ma.
Ma'am, you need to give them permission to unmute, ma'am.
Okay, okay, sir. So I actually.
There is an option ask to unmute. When you click that, students will get the promptness.
Okay.
Like whomever you want to speak, just click on the ask to unmute tab, ma'am.
Okay, sir. No, I'm going on teaching now, sir. I don't know whether they have understood or not, or is there any problem for them? How would I know? That's the reason I want to listen for 4-5 students' response, sir. That's why I'm asking them. So, Sri Harshini.
You can unmute Harshida.
Madam,
Yes, Nana. How are you?
fine, madam.
So, which chapter are we going? We are in now?
Playing with magnet, ma'am.
Very good, Nana. What is magnet, Nana?
Magnet is attracting to iron
Very good.
things, ma'am.
Very good. So I told you to note down the point. What is magnet? So did you write it, Nana?
No, ma'am. Signals not found here.
That's fine. That's fine. That's fine. Not a issue. So have you done the home fun? Like I told you to take the magnet and roll in the soil, and you'll get some iron fillings. Have you done it?
Yes, ma'am.
Did you find any iron fillings?
Ma'am?
Did you find any iron fillings from the soil, Nana?
Yes, ma'am. Some black coming.
Very good, very good, very good. Are they with you now?
No, ma'am.
But very good, Nana. Nice response. Very good.
Thank you, ma'am.
Very good, Nana. Mute yourself. Good girl. Keep it up.
Thank you.
Okay. Now, Nana, mute yourself. Let us give chance to others to speak. Komal. Komal, unmute, Nana. You can't unmute. There is an icon. Mute icon. Very good. Very good. Good afternoon, Komal.
Good afternoon, ma'am.
How are you, Nana?
Fine, ma'am.
Who discovered magnet beta? Who discovered magnet? You don't know? Are you there first day?
Yes, ma'am.
Then tell me who discovered magnet? You don't know? Oh God, pass. Now next, which is the strongest magnet, Nana?
Bar
Komal. Huh? And Shiva also playing, Nana. Don't gather so many members and don't play with the mobiles. It is not good, Nana. Use your time sincerely and try to listen sincerely, Nana. This is not a game, right, Shiva? And Shiva. Next for you only. I'll ask you only questions. Every day I will ask. Komal, you don't know. Try to find the answers, okay?
Yes, okay, ma'am.
Okay, now Shiva will answer. Shiva, you can mute, ma. Mute yourself. Shiva, unmute. What is that expression, Nana? Come on. There is an icon. Just you click on this. Nana, don't do time pass with the mobiles. Very good. Come on. Say good afternoon. Shiva, good afternoon. Click on that. Enough. Enough. Don't mute again. Don't mute again. Once you click on that, leave it. Time is running out, Shiva. Don't waste the time. Yeah, stop now. Don't touch the mobile.
Yes, teacher.
Good afternoon, Shiva. Can you please tell me the lesson name?
Yes, teacher.
Tell me the name, Nana. What is the lesson name? You are laughing.
No textbook.
No textbook, even though I am repeatedly telling that at the beginning of the session, good afternoon, children. This is science subject. Now we are in chapter 2, playing with magnets, blah, blah, blah. I'm explaining now.
Yes. Yes, ma'am.
Yeah. Then why are you not